times, which is really horrible resolution, but you will get map data really, really, really fast. We always leave these set to 1. It's up to you guys to change them. We let it set to 1 for the best resolution. Underneath that, we got a readout zone, either full spectrum or image. For RTD display, we always leave it on the spectrum mode. That is because we have the chip masked down. So any pixels on this CCD chip that do not receive light, we have turned them off. Because if they're not receiving data, the only thing they do is generate noise. So to help the signal-to-noise ratio, we shut off all of the pixels that are not getting any light. If ever you have an issue or there's no data, or you're talking to somebody, one of us, we might tell you, well, use the full chip, in which case you come in here and click full, because if your data has fallen outside of the determined readout zone, your computer will read no data. But then if you open the thing up to full, and your data all of a sudden appears, it is because your stuff has shifted on your chip and you need realignment of the system. But we always leave it in spectrum mode to get the best signal-to-noise ratio. And down here is just letting you know the exposure time in the bottom corner that you have this window set for. Alright, acquisition again. RTD options. Lots of fun stuff in here. So, options going down. Top one is exposure time again in seconds. You can set it here or you can set it down the bottom of the window. Many of these icons and options are repeated in several locations throughout the software, hidden under several different icons, but they're all the same exact thing and control the same stuff. Again, we have acquisition time, 1 second. Accumulation number is 1. These are copied from down here in the acquisition window at the bottom. The photo bleaching time, I actually believe that is the amount of time for when you have a sample that has a high fluorescence background. Sometimes you can get fluorescence absorption. If you actually leave your sample sitting under the laser power, over time, the fluorescence will actually decay some as your thing gets absorbed. So here you can actually set a time limit that you wish to let your sample just sit there and hang out under the laser before acquiring your data. Next under again, we have a binging factor. Now this one here applies evenly to X and Y at the same time. So you can just select it and same thing, 1, 2, 3, 4, 8, 16, or 32. The higher you go, the more resolution you sacrifice, but the faster you will get your data. Accumulation mode. A lot of these other options, this software is used to power multiple instruments for multiple divisions. So not all of these options apply to all instruments. So next we have accumulation mode. You always want to leave this on average for this instrument. Next is a spike filter. This is for the instrument to automatically remove solar spikes or cosmic flares as they might be called. We have 3 options. Obviously one option is off. Next option is on auto add, and the third option is just on. For the spike filter program to work, what it does is you take multiple spectra in one spot. It averages the spectra together, or not, and compares them. If there's one data point, if there's one data peak that is in one spectrum, but it's not in the other 2, like if you just did 3 acquisitions in a row, and there's one peak that's not in any of the other 2, the software would automatically remove it. It would assume that it's a spike or cosmic flare, and it'll take it right out. For on, you must have more than one acquisition for it to work, because it needs something to compare it to. Then we have on auto add. On auto add means if you put the auto add on for the spike filter, if you go to take 1 acquisition only, the computer will actually go, no, you need 2 acquisitions. And this computer will automatically take a second acquisition regardless of what you tell it, because it needs something to compare to in order to know what's a spike and what's not. For now, we leave this off. Here's our autofocus. We have 4 options: off, before acquisition, before each point, or in limit points. Off means off. Before acquisition means when you go to start your map or your single acquisition, it'll do the autofocus 1 time, and then it'll run your map or take your data. If you select before each point, It will go, if you're doing a map, at each point, it'll try to autofocus for you. And it'll adjust the focus at every single point, then acquire the data. Any of these options that you turn on will exponentially make your map longer. So if you have a 15-hour map and you tell it, well, do an autofocus before each point, it's probably now a 17 or 18-hour map. Every little option that you add makes things go longer. Using in-limit points, what that'll do, the stage will move. You have to have your map defined. The software will automatically go to one corner of your map, then it'll go to the other corner of the map. It'll see the depth difference between those two corners, and then it'll pick an area in the middle, and it'll use that to go around and determine your whole map. Next, under signal mode, we're going to leave that guy alone. You have dark mode, dark subtract, signal minus dark. We always use signal because we don't use dark or signal minus dark, because on our software with this system, we've already calculated the dark current of your CCD. All CCD chips have what's called a dark current or a background, usually around 1,000 counts. So right now, when we do a 0, your baseline is at 0 because we have the software already set to remove this information from your background. If you try to use this dark or signal minus dark, it'll like double and triple remove it, and then your background will be down at like minus 1,000, minus 2,000. So just always leave it signal. Next down we have here is auto exposure. Auto exposure works kind of well. It's really neat. You come down here, you can turn it on, and you can hit set. So now what this does, if you're working with an unknown sample, you have no clue what you're looking at, and you're still trying to learn, but you know, for example, that you need to get about 1,000 counts of data to have something that would be usable for you to look at and manipulate. You could come and set this window here. You have test exposure time, then you have minimum and maximum exposure. So it'll take a quick 0.2 scan right now to just see what kind of data it gets. Then it would try 1 second first as the minimum time, and at 1 second, if your signal is 1,000 counts or higher, it'll stop and say we are done. If not, it'll keep trying to a maximum of a 10-second length exposure in order to get you a maximum signal of 1,000 CPS. This does not adjust the focus, position, or anything. It automatically adjusts the acquisition time. If you don't want to do this, you can always just try it manually and look at the data yourself if you're sitting there. But these are all the auto features. Next down here is a shutter mode. There are 3 selections: auto, open, and closed. If you ever come in to use the instrument and you start trying to acquire data and you don't get any data and you don't hear your shutter clicking, there are several things that could have happened. One, somebody could have flipped the switch on the control box that says micro. They could have turned that switch down to where it says macro, in which case your shutter will not work. Or they could have flipped on the control box the shutter 1, shutter 2 switch. They could have flipped down the shutter 2, in which case your shutter will not work. But if it's on the wrong shutter control, 1 or 2, you should hear the shutter chattering inside the system because there's no power going to it.